So here is a two-sample mean t-test. Okay, so now we have two different means. So when do we use this? We use this test when comparing a numerical variable with a categorical variable of two levels. So now we have something that's numerical, so we left the whole categorical sequence, and now we have something that's numbers. And now we want to compare it with a categorical variable of just two levels. So heights amongst males and females, who tends to be more taller, males or females? And heights here will be the numerical variable. Males and females, there's two levels, and that's the categorical variable. So using our data set, is there a difference between GPA amongst males and females? Okay, so one thing to really notice, let's go to our data set. We can go ahead and graph these two. And one way that we can graph them is using a box plot. Okay, so if we use a box plot just to kind of look what it looks like, so GPA, and we want to look at males and females, so that's just gender. What you can see is that you don't really see such an increase in the GPA. So you do see this type of maybe a little bit in the females, but it's considerable. So this graphically, you can kind of see if there's any differences, any notable differences. If not, another way that you can do it is you can look at summary statistics columns. So let's look at the GPAs and let's group it by gender one more time. And then here you can kind of see that the mean GPA of females is a little bit higher than the mean GPA of males. Okay. So here are some of the summary statistics. Now, is the mean GPA of females considerably higher than the mean GPA of males? Okay, it's 3.4, significantly higher than 3.2. Okay, so let's do the hypothesis test now. So this was going to be a two-sample t-test because you have the GPA, which is the numerical, with the gender of two variables. That's the categorical. The gender is a categorical variable of two levels. Okay. So how are we going to write the null and the alternative? So mu1 is going to be the mean GPA of males. Okay, very similar to the way that we did it with proportions. Mu2, okay, is going to be the mean GPA of females. Okay, so the sample number 1 is going to be the mean GPA for males. The sample number 2 is going to be the mean GPA for females. So my null hypothesis, HO, is going to be that mu1 equals mu2, which means that the GPA between males and females is the same. GPA is same for both males and females. HA is going to be that the mean GPA between these two is not the same. Not the same. So there is some difference. Okay. So we want to do this at alpha equals 0.05. Let's figure out what my p-value is going to be. Okay. Now this is going to be a z-test. A t-test. So let's go ahead and do this. So we're going to go ahead and click on stat. We're going to click on summary stats. We're going to click on t-stats, to sample with summary, because we're going to summarize all of this. Okay, so what we're going to do, we're going to go ahead and summarize a lot of these variables. Okay, so if I can get this to work, let me go ahead and do this first. So some of the things that we really need to take a look at is for sample number 1 and sample number 2, we first need to see what the mean and the standard deviation is for all of these. Now you have to be very, very careful with this. So sample number 1 was males. So for males, you have a mean GPA of 3.28. So let's just round a little bit. And a standard deviation, a sample standard deviation of 0.475. So let's just round to 3 decimal units. And then we have 40 males. Now for females, if you look at it, you have a mean GPA of 3.42, a standard deviation of 0.475, and you have a total number of 39. Okay, so what we're going to do, we're going to put in all of that information into our test. So I needed all of this information. So here's the mean, here's the standard deviation, okay, and here's the n. Okay, so for the mean, sample number 1 was our males, okay. So what we have is that the mean for this one is going to be 3.28. So 3.28. Our sample standard deviation is going to be approximately 0.475. And our sample size, we have a sample size of 40. Okay, so that's for the males. Now, sample number 2, we said that was going to be females. That's going to be GPA of 3.42. Okay, a sample standard deviation of 0.475, and the sample size in this case is going to be 39. Okay, so that's what we have. Okay, here is going to be a hypothesis test. We don't want it to be greater than or less than. We're going to keep it at not equal to. We're not going to do anything with the pool variances. We're just going to go ahead and click compute. Okay, and here is my output. My output is here is a sample difference. So the differences between the GPAs is negative 0.14. Okay, and then we can see, look at the standard error, degrees of freedom, other stuff, and the p-value, which is what we need, the 0.1942. Okay, this is 0.1942. In this case, we see that our p-value is much greater than our significance level. So can we reject this? No, we can't. So we fail to reject. This is going to be fail to reject. Okay, so cannot say that there is a difference. There's a difference in GPA among gender. Okay, so that's basically all it is to it. So you do have to get a couple of the summary stats from here in order for you to do some of the testing so that you can plug them in. There's no really easy way to do it. So you don't want to do it with data. Make sure that you do it with summary. Okay, so that's it for this next test.